Good morning, good morning, everyone. My name is Mudassir Khan, and today I will be presenting my MSc research project titled Customer Segmentation in E-commerce using Deep Clustering. This work was completed under the supervision of Professor Jaswinder Singh at National College of Ireland. The challenge: understanding the modern e-commerce customer. As e-commerce continues to grow, businesses are collecting massive amount of transactional data. However, simply collecting data is not enough. The companies need to understand customer behavior to stay competitive, personalize marketing, and improve strategic decision making. Customer segmentation is a key technique for this, but traditional methods like K-means often struggle when the data is high dimensional and non-linear, which is very common in e-commerce. This challenge motivated the focus of my research. What this research aims to achieve? The goal of my project was to explore whether deep learning based clustering can offer better segmentation than traditional method. To do this, I followed three steps: extract and prepare the data, generating RFM features for each customer, develop three deep clustering models: autoencoder with k-means, variational autoencoder with k-means, and deep embedded clustering. Evaluate and compare them using standard clustering metrics to see which model performs best. This structure allowed me to systematically test how deep clustering improve customer segmentation. The evolution of customer segmentation. Traditionally, segmentation uses RFM analysis combined with k-means. While this approach works, it assumes clusters have simple shapes and does not perform well on complex pattern. Deep clustering, on the other hand, uses neural networks to learn powerful presentation automatically. Autoencoder compares data into meaningful lower dimensional features, and DEC model can even learn clusters and representation at the same time. This evolution from traditional to deep learning method is at the core of my research. A structure quantitative approach. For this project, I used the UCI online retail dataset, which contains over 1 million e-commerce transactions. I cleaned the data, removed cancellations and missing values, and re-engineered RFM features for around 5,900 customers to ensure better clustering. I removed outliers and applied standard scaler. Once pre-processing was completed, I trained and evaluated the three deep clustering models. The three deep clustering architects. Here's the summary of the model. Autoencoder with k-means. An autoencoder reduces the dimension to a 10-dimensional latent space, and k-means clusters this presentation. Variational autoencoder with k-means. A variational autoencoder learns a probabilistic latent space which leads to smoother cluster boundaries, followed again by k-means. The DEC, this model combines representation, learning, and clustering into a single end-to-end process. Comparing these models help determine which method best capture customer behavior. How do we measure good clusters? To evaluate the models, I use three common clustering metrics. Silhouette scores: higher is better, shows how well separated clusters are. David Bolden index: lower is better, shows cluster compactness. Kalensky-Harabas score: higher is better, measure variance separation. Using multiple metrics give the more reliable assessment of the models. Which model performed best? The result clearly showed that autoencoder with k-means outperformed both VAE and DEC on all three metrics. It achieved the highest Silhouette score, the lowest Davis-Baldwin index, and the highest Kalensky-Harabas scores. This indicates that the cluster produced by autoencoder with k-means were the most compact and well separated. So this model was selected as a best approach for interpreting customer groups. Meet the customer, the four segments. Using best performing model, we identify four meaningful customer segments: champions or VIPs, 8%, highly active and highest spenders, loyal high value customer, 14%, consistent, reliable buyers with strong purchasing behavior, potential loyalist, 51%, the large segment with moderate frequency and good growth potential, at risk customers, 27%, haven't purchased in a long time and have low spending. These customers are distinct, interpretable, and highly actionable. Turning segment into strategies. Once the segment were generated, the next step was to map them to business strategies. VIP retain them using exclusive rewards and personalized treatment. Loyal high value encourage them to upgrade towards VIP status through targeted promotion. Potential loyalists engage them with loyalty program and campaign to increase purchase frequency. At-risk customer re-engagement campaigns, discount, or feedback survey. These strategies show how data-driven segmentation can directly support business growth. A 2D view of the cluster. Here we see 2D PCA projection of the 10-dimensional latent space learned by the autoencoder. Each point presents a customer and each color is a segment. We can clearly see distinct separation, especially between high value customer and at-risk customer. This visual confirmation supports the quantitative results. Key findings and contribution. My research found that the autoencoder with K-means is the most effective deep clustering approach for this type of e-commerce data. The project identifies four strong customer segments that are both interpretable and actionable. Overall, the deep learning approach proved to be the powerful way to extract meaningful business intelligence from complex customer transactions. Avenues for further research. There are several ways this work could be expanded. More extensive hyperparameter tuning could improve model performance, especially DEC, incorporating new features like browsing data, demographic, and or product categories, e- exploring advanced models like graphic neural networks or transformers, and finally developing dynamic segmentation to track how customers shift between segments over time. These ideas open up exciting opportunities for future work. Now I'm going to explain the code implementation. In the first cell, I import all the necessary libraries. Pandas and NumPys are used for data handling, Matplotlib and Seaborn for visualization, and scikit-learn for pre-processing. Dimensionality reduction, clustering, and evaluation metrics. TensorFlow and Keras are included because I build and train several deep learning models later. I also suppress warning for cleaner output. Next, I loaded the online retail dataset using the appropriate encoding. Here I display the shape of the dataset and uh, a quick preview using head. This step helps confirm that the dataset loaded correctly and gives an initial sense of variable we'll be working with. In this cell, I explore the data set by looking the data types, memory usage, missing values, and descriptive statistics. This gives me clear understanding of the data quality issues, for example, missing customer's ID or unusual numerical values that need to be addressed. Data cleaning. This cell focuses on cleaning the data set. I remove rows with missing customer's ID and I also filter out negative or zero quantities and prices, which usually represent return or data entry errors. I create a total price column and convert invoice date to proper date time format. Finally, I print how many rows are removed. Here I construct the core RFM feature frequency. recency, and monitoring. Recency measures how long it's been since a customer last purchased. Frequency counts the number of unique invoices, and monetary calculate total spend. Customer with non-positive spending are removed, ensuring clean behavioral metrics for segmentation. Uh, in this cell, I visualize the distribution of recency, frequency, and monetary using histogram and box plot. These plots help identify data skewness and extreme outliers, which can affect clustering performance. I compute the visualize the correlation metrics of the RFM feature. This heat map helps verify relationship between attributes. For instance, where the customer who buy more often also tends to spend or also tend to spend more. To improve the quality of the clustering, I remove outliers using the IQR method. By filtering extreme values, the resulting data set becomes more stable for downstream machine learning models. Next, I standardize the RFM values using standard scaler because clustering and neural network are sensitive to scale. This ensures all features contribute proportionally. In this cell, I define a custom encoder. In this cell, I define the custom autoencoder. The encoder compresses the three-dimensional RFM data into a lower dimensional space while the decoder attempts to reconstruct it. I include drop out layer to improve generalization. I train the autoencoder with early stopping to prevent overfitting. After training, I plot the training and validation loss curve to verify convergence. Using the encoder part of the train autoencoder, I extract latent features. I then run k-means with four clusters on the encoded data and display the cluster distribution. I then implemented the variational autoencoder, which learns the distribution rather than a fixed encoding. After training the VAE, I extract the latent space means and cluster them using k-means. This approach often creates a more structured and latent space. The third deep learning model is DEC, which jointly learns feature representation and cluster assignments. I first pre-train it as an autoencoder, then refine the clustering through a target distribution and KL divergence optimization. Finally, I extract the refined embedded and apply k-means. This cell model evaluation, this cell evaluates all three model using three clustering metrics: Silhouette score, higher is better. Davis Baldwin index, lower is better. Kalensky Haraba score, higher is better. The results are organized into a data frame for easy comparison. Metric visualization, I visualize the performance of each model for each metric using the bar chart. This makes it easy to compare which model performed best overall. Using a simple voting method, counting which model wins the most metric, identify the overall best performance segmentation model. To visualize customer segmentation, I reduce the encoded feature to 2D using PCA. I then plot each customer colored by their cluster. This provides a clear visual intuition about cluster separation. I profile the cluster by computing the average RFM values for each segment and visualizing them in group bar chart. This step bridge the gap between the technical cluster and business insights. I save the trained model including the encoder, VAE, DEC, K-means model, and scaler so they can be reused without retraining. In this cell, I interpreted each cluster in simple business term. Champion, loyal high spenders, at-risk customer, occasional buyers. This turn clustering result into actionable marketing insight. I test the model pipeline on sample customers showing how new RFM data can be assigned to one of the cluster. This demonstrate the practical usability of the segmentation system. Finally, I export the full RFM dataset with cluster labels to CSV file, which can be used for CRM integration and targeted marketing campaign. To summarize this notebook builds a complete customer segmentation pipeline from data cleaning and RFM engineering to deep learning based representation learning, clustering evaluation, and business interpretation. By combining RFM with deep learning, the segmentation become more robust and expressive than traditional method. I've also created a web application where if we go ahead and enter the days since the last purchase, for example, if we enter 9 days with a frequency of order like 6 and the total money spent that is $65 and we click on the predict customer segment, it gives the moderate recent customers. If we take a recency days as like 50 days, frequency of number of orders like 3 and total monetary spend is like 15 and we click on predict customer segment shows moderate recent customers. If we take 150 or if we take like 250 frequency like number of orders like 14 and money spent that is $50. If we go it's a loyal high value customers. Thank you so much. That's all for that's all for my project.